Bismillahirrahmanirrahim and Assalamualaikum to all my panels. Today, I would like to present my final year project which titled Simulation of Combustion in Solo Stove. My name is Muhammad Fadhil Aiman bin Abdul Rahman and this project is undergoes the supervision of IRPS Dr. Zainoor hailmee bin Solihin. Without further ado, let's go to the introduction section. So first of all, as we all know, that at developing country, the biomass cook stove have been used in these countries since decades ago, and the research have studied that have been studied shows that this cook stove combustion produce harmful gases emission and lead to various type of disease for humans. Okay, so this situation leads to various study and research of biomass cook stove design to increase the efficiency while reduce its harmful gases emission. So the improved biomass cook stove have already been designed throughout many years, and this improved cook stove have been used in many countries. The development of the biomass cook stove still been improved nowadays, and many technology have been implemented to this biomass cook stove. And the rocket stove and solar stove is among of the improved biomass cook stove. Okay, so let's go to the second slide, which is so from this slide we can see at the left side rocket stove and the right side is solar stove. What is rocket stove? Rocket stove have been used in many countries. It is an efficient cook stove, and from my observation, there is many research study about the combustion process in the rocket stove, and by the many years, this stove have been improved nowadays, and the efficiency have been increased because of the studies. While at, while on the other hand, the solar stove, the solar stove is a very new improved design of biomass cook stove. It is simple and efficient and very efficient cook stove. It it design have two inlet, which is at the bottom and at the top. So, but there is no specific study have been done for this cook stove. Okay, from my observation and studies, I determined that there is no study or research that have been done that refer to solar stove geometry. If the research, I have only found the research that have been done to rocket solar stove geometry. So no CFD. The second problem is no CFD approach to study the biomass cook stove. This solar stove is efficient, but there is no any CFD approach that have been used to study this solar stove. So from this problem statements, I have produced the objective that will be highlighted for this whole project. First, I want to use the objective for this project is use CFD approach, which is CFD software, to study the flame behavior that refer to solar stove geometry. And next, after that, I will determine the final temperature of the flame, which is expected to the air velocity. So the air inlet velocity will be manipulated while the CFD software will produce the final temperature of the flame, and the result will calculated at the end of the project, while the flame behavior will be determined, which is laminar or turbulence. So we can see how the flame is produced in the solar stove and the behavior like speed and temperature of the flame. Okay, let, let's move to the next session, which is literature review. For the certain time, I have observed and researched some research paper and journal to be be references for this project. So in this presentation, I will present about some of literature journals from the research journals that have I been found. Okay, first of all, Egenbot 2011, Smith 1989, McCarthy NA and Biden KM 2015. So basically, Egenbot is a research about the simplified model of the rocket stove to understand more about natural convection that have been driven by biomass cook stove. Next is Smith, which is uh, tell us about how the input stove have been changed for the throughout this year and use some analytical model to observe the efficiency, where the McCarthy is model of modeling of household biomass cook stove that have been improved by through these years. So the papers will focus on rocket stove combustion design and heat process studies, and there is no CFD approach regarding to study the heat combustion in the rocket stove. So they only use analytical approach to solve the conclusion, and for this project, these papers will be references for the variable of parameters. So density equation also have been referred to these papers. Okay, so the first the first some basic of equation that have been carried out for this presentation, like heat adhesion equation. So you can see the rocket stove uh, the rocket stove section, and next there is some chimney effect for the rocket stove. So the air mass flow rate will be derived to this equation, while the fuel mass flow rate also have calculated from the fire power and its system value. So the parameters values in this project will be referred to this equation. So serial saga is the papers focus on the mathematical tool for predicting thermal performance of natural gas biomass cook stove. So they use some testing and experimental to study about the thermal performance of the combustion process. So it explains the heat transfer in each zones of the rocket stove, which are conduction, convection, and heat radiation for the combustion. So the parameters will be act as references for this project. So next, the Gandhi Good also study about the simulation of rocket cook stove geometrical aspect for the performance improvement. So this study is almost the ANSYS is like this software approach is like my project, but they only focus on the heat distribution on the rocket stove. So it also only use height of the chimney as the manipulated variable. So while this project use the air and inlet velocity as manipulated variable. So the result will, as you can see, the result uh, after have been manipulated is been like this. So next is hydrology. The this paper produced this paper study about the product development using CFD estimation of energy efficient. So there is not there he did not use CFD program of the rocket stove, but it used biochar rocket stove. So the velocity and heat temperature will be references for this project, where the assumptions for its boundary condition have been referred to this project. As you can see, the result for the paper for the for hydro study is like so the body name and body type and some boundary condition that have been referred. Okay, so this from the literature review and from the my supervision advice, There only scope for this project. There is only focus on two items only. So first of all is this project use CFD approach to study the flame behavior, which the geometry model is referred to solo stove geometry, while it determines the final temperature of combustion process, which is respected to inlet velocity. So these two items only be observed at the end of the project, not the not the other things that have been result from the CFD software. So the limitation for this project is the fluid flow is in steady state and in three-dimensional flow. The simulation of combustion is by CFD software approach only, not analytical model or anything else. Wall is assumed adiabatic and no experiment conducted for this whole project. Verification from the result will verify from previous researches that you have looked at the previous slide, and the design model in the software and the CFD software is referred to solo stove geometry only, not the rocket stove. Okay, let's move to the next slide, which is methodology. In methodology, I will show you the process for how this project undergoes. So first step is the I have studied the combustion process in the cook stove. So I will have understand more about the combustion process. Next, I will find the previous research journals to be references that you all see in the literature review section before. That is the research journals that referenced have been references for this project. Next, I have also construct the literature review and learn the mathematical model from these research journals. So I have clearly see on what to do and take some mathematical model for the next FAP2. After that, I will start the after undergoes these three steps, I will undergo start to design the 3D model that refer to the solo stove geometry by using CFD approach. So after the modeling, I will mesh the 3D model in the CFD software and adjust the meshing of the 3D model. Before start the simulation, I will insert the some boundary condition such as velocity at inlet, fuel mass flow rate, and the temperature of the wood, and etc. So after the boundary condition have been inserted, so I will run the simulation. So after several iteration, which is I use 1000 for this proposal. After this proposal, so I will analyze and record the data that have produced by CFD software in the CFD software itself. So it is better and safe for the next FFP2. So this is the whole process that have I been done for to complete FFP1. And this methodology also will be used in the next FFP2 as a references. Next, the expected results. So first of all, the boundary condition that I have inserted into the CFD program before run the program. So I have put temperature woods, temperature air, velocity air, fuel mass flow rate, as you can see at the slide. Next, let's go to the next results. So as you can see at the left side is the 3D solar stove geometry that have been designed that refer to the solar stove, that to the actual solar stove. It has 16 holes and there is two inlet at the bottom, which is fuel inlet at the center, while the fuel inlet at the side of the fuel inlet. So after the design have been completed, it will go to the meshing process. So the machine process that you can see in the slide is the after has been set to the fine mesh, and it is very stable and also very fine. Next, after insert all the boundary condition, the simulation will be start, and this is the results. Okay, as you can see, this is the results after 1000 iteration for the simulation of the solar stove. So as you can see, the fuel inlet is at almost 900K, while the fuel inlet is 4 5 300 Kelvin. But after it's been simulated, the air temperature increased to the 4.700K. So as you can see, the the flame behavior and the direction is try to go to upwards to fulfill the whole section of the solar stove. So the temperature is high at the wall of the solar stove, which is logic, which is very logic. Uh, and the temperature highest at the top is at almost 7,000K, 700K, which is almost nearly as the previous research from the research journals that have I been found. So it I can say that this simulation is completed, and it is so is have been verified from the previous research journals. Okay, so this is the temperature behavior, the flame behavior of the after combustion, it during the combustion. So next, let's go to the behavior of the flame in terms of the velocity streamline. So as you can see, the streamline of the flame is turbulence, which caused which caused by the secondary inlet of the solar stove design itself. So you can see the velocity streamline that have been circling around the solar stove. It is the air inlet did not just go to upwards and fulfill whole solar stove, but it circling around all the solar stove to distribute the flame temperature to whole solar stove sections. Okay, so as you can see, this is the velocity streamline values, and the it is quite constant at the top, which is 6.6 meter per second, so which is quite high. So at the to improve this, maybe the velocity at inlet will be changed at the FIP2. So the whole results will be improved and will be specified and emphasized at the FIP2 after manipulated variable will be setting at the boundary condition. So the results have been completed and will be studied further at FIP2. Okay, so the conclusion. The conclusion is the simulation have successfully completed. The final temperature of the flame have been determined, and the formula velocity stream shown. The behavior of the flame can be observed. Different results will produce in the next chapter, and the future study will continue in the next semester. Okay, so that's all for me, and I thank you to all my panelists for hearing me out during my presentation. And I also want to say thank you to my supervisor, Dr. Zainoor, for help and advise me to complete during the project progress. Okay, so that's all for me. I really thank you for all my partners and see you at FYP2 presentation. Thank you.